All right, so I'm recording the session now. Okay, chapter 2, capacitors and dielectrics. Okay, so our first subtopic is capacitance and capacitors in series and parallel. So what is mean by capacitance? And we also have capacitor connected in series and parallel. How to calculate the capacitance for capacitor in series and also capacitance for capacitor in parallel. So there are formulas, to calculate. So today we're going to learn. First, we need to understand what is actually capacitance. And this is the formula. C equal to Q over V. Well, firstly, what is capacitor? Capacitor is a device that capable of storing electric charges or electric potential energy. Capacitor, this one. You see a lot of these components in your, maybe in your aircon, in your fridge. If you look at a circuit board, they have a lot of these capacitor. Okay. Like a big size one, they store more charge. Like the small one, they store less charge lah. Okay, small capacitor. So they can store charge. Something like battery, but it's a temporary battery. Temporary battery. So it discharge very fast. In a large amount of energy. So it store electric potential energy, just like the battery. Just that it is the temporary battery. Consists of two conducting plates separated by a small air gap or thin insulator. So actually capacitor is parallel plate. Two parallel plate separated by a small air gap in between. You see, there's nothing in between. So that means there is a small air gap in between. Or sometimes they put a thin insulator. Normally they actually put a insulator in between, or we call it dielectric in between. Okay, this dielectric can increase the ability to store charge. Increase the ability to store charge. We will learn about how it increase the ability to store charge later on. Okay, so the insulator, in between is not a conductor. It's not a conductor. It's an insulator. The insulator can be a paper, oil, mica, ceramic. Okay, so the plates, I say it's two parallel plates. You remember? Do you remember you learned about parallel plate before? Where is it? Let me show. Where is chapter 1? Let's look at chapter 1. You learned about parallel plate before in chapter 1. This one, you see the parallel plate. So in between the parallel plate has uniform electric field. Uniform electric field. You see the electric field lines, they are uniform. All the electric field strength, they are uniform. So this parallel plate actually is a capacitor. This is a capacitor. Now you realize, it is actually a capacitor. Alright. What happened? Okay. Right. Now, so this is the parallel plate with uniform electric field. It is actually capacitor. So two ways of two kinds of symbol is the same. Now, uses of capacitor. You can find this in the photo flash unit. That means you can find this in the camera. Camera. Capacitor store a large amount of energy which can be released in a flash when triggered. So like your handphone has a flash unit, right? Can have a flashlight. That one use capacitor. Camera also has a flash unit. So they have capacitor, because they can store a large amount of energy and release in a short time. Giant laser can produce a powerful laser. Okay, so capacitance. What is actually capacitance? Ability of capacitor to store charge is measured by capacitance. So capacitance means ability to store charge. Ability of a capacitor to store charge. So how we understand capacitance? So capacitance is the ratio of the charge between the plate to the potential difference between them. This is the formula. See, ratio of charge over potential difference. Ratio of charge over potential difference, or sometimes you put it as voltage. Okay. This is the formula lah. This is the definition for capacitance. C is the capacitance. Okay. Charge over voltage. Charge over potential difference. Q is the charge of one plate. And then potential difference is voltage across the two plates. The unit for Q is coulomb, and the unit for V is volt. Okay. The charge stored is directly proportional to the potential difference across the plate. Okay, this one I will explain later. It is a scalar quantity. So capacitance is a scalar quantity, not a vector. The unit for capacitance is farad. Okay, C is farad, or coulomb per volt, because follow this formula. Q is coulomb, V is volt. Yeah, coulomb per volt. It is always a positive quantity. So this is the example. Okay, I will explain more about this formula now. Okay, in the OneNote. Yeah, actually this is the old notes. Yeah. I have you know the Planck explains physics notes I posted. This is the notes lah. Yeah, I explained about this lesson in my YouTube also. Yeah, if you want to know about this explanation, you can refer to my YouTube. Yeah, this year I just used our notes. Yeah. Okay, so capacitance. Yeah, what is actually capacitance? Also, I will repeat here. What is actually capacitance? Capacitance is ability of a capacitor to store charge. Why we say like that? Yeah, why we say it is ability to store charge? Okay, we know that we all charge. How to charge a capacitor? How to charge a capacitor? This is a capacitor. At first, it is actually neutral. Yeah, uncharged parallel plate. Okay. Now, if you want to charge this capacitor, yeah, to store some amount of charge inside the capacitor, we connect it to a battery. We connect it to a battery. Then we connect it to a battery. So we know that battery has a positive and negative terminal, right? Once you connect the capacitor, this is the battery lah, or cell, and above is the capacitor. Okay, once you connect to the battery, normally we have another resistor over here to protect the capacitor. Yeah, we have a resistor there so that we reduce the current flow in the circuit, so that the capacitor does not charge quickly, yeah, or does not burn off lah. Yeah, does not short circuit, does not burn off. We put a resistor there to protect the capacitor. Normally that. Now, once you connect the capacitor to a battery, then the charge will flow. How will it flow? Normally electron will start to pull to the, electron charge will start to pull from this plate to the positive plate, and then electron will also when you connect this capacitor to a battery, so this positive terminal will pull electron from one plate, and deposit at the battery. So what happened is this plate become positively charged. Understand? Before that is neutral. Uncharged. These two plates are uncharged. But once you connect the capacitor to a battery, then electrons will start to being pulled from capacitor, and pulled by the positive terminal of the battery. So electron will go from this plate and deposit at the positive terminal. And then once this plate will become positive plate. Why become positive plate? Because it loses electron. Because it loses electron. Because where is the electron? Because the electron is being pulled to the positive terminal. Understand? So this plate has already become positive. So what happened is, when this positive plate will start to pull electron from the negative plate of the negative terminal. It will pull electron from the negative terminal of battery. Yeah, so electron will flow from negative terminal and deposit at this plate. All the electron will deposit at the opposite plate. Here, so this plate become negative terminal. This plate will become negative. Why electron is being pulled to deposit at this plate? Because of this positive plate. This positive plate will pull electron from here, from the negative terminal, and deposit at the opposite plate. But why, class? Why the electron cannot flow across? Why the electron cannot flow across the parallel plate? Why? Why cannot the electron will all deposit at this plate and cannot flow across the air gap between? Go to discharge the positive plate here. What? Why? Why the electron cannot flow across? Because in between they are vacuum or separated. Just now we learned what? What do we learn? In between them is separated by a small air gap or insulator. Insulator is not a conductor. Understand? Why it must be separated by insulator? We call it dielectric. Yeah? It's either air or insulator. So insulator cannot conduct electric. Understand? So in between them, it is either air gap, or we call it insulator. Insulator. So we call it dielectric. Yeah, if air gap or vacuum is without dielectric lah. This one is no dielectric. No dielectric. If got insulator in between, or like paper, oil, that one is called dielectric. Okay. So because there is separated, yeah. Why we must have an air gap in between? Why? Because we want to prevent the electron from here to jump across to discharge or neutralize the positive plate. That is the purpose. We want to prevent the electron from the opposite plate to cross over. If the electron can cross over, that means it's always neutral. We cannot charge up the capacitor. Understand or not? I want to see your thumbs up if you understand, class. Where's the yeah, good, yeah, thumbs up, very good. Where is it? Yeah, sorry lah, because I only have one monitor, so very hard for me to see your comment. Yeah, so I have to always go to Google Meet and see your comment. Yeah, so why in between you must have insulator? Because that is the purpose. We don't put conductor. If you put conductor, class, if you put conductor, the capacitor forever cannot charge up. Because if you put in between, you must have an insulator. If you put conductor, yeah, that means in between here, if you put this as a conductor, yeah, the conductor cannot, because forever it cannot make it positive negative plate. Forever the electron cannot build up, the positive and negative terminal cannot build up. The electron can cross over, and then neutralize the capacitor. Neutralize, or we say discharge the capacitor. We want it to store charge. We don't want to discharge. If discharge already, that means it doesn't store any charge. So we don't want the electron to cross over. We purposely don't want the electron to cross over. We put an insulator in between so that electron cannot cross over, so that the positive and negative plate can be built up. That means when the positive and negative plate is built up, means it's stored charge already. Understand? It's stored charge. When positive and negative terminal is being built up, we say potential difference is built up already. Yeah. When the capacitor, you have a positive and negative plate, that means it already when it store positive Q, negative Q over here, that means you have we in previous chapter, where is the previous chapter? Chapter 1. Yeah. I see you have positive and negative plate. Why we must have positive and negative plate? Because you learn about this. You see that? We purposely want to have positive and negative plate because they have potential difference. 100 volt, 0 volt, right? We purposely want to have a potential difference in between. Okay, so next time this one will become 100 volt, this one becomes 0 volt. So that means you have delta V. That means 100 minus 0 is 100 volt. So when the capacitor is being charged, it build up a potential difference between the two plates. Understand? Like your battery, your battery, you have a 9 volt battery. You have a 1.5 volt battery. Remember? What is mean by 9 volt and 1.5 volt? That is the delta V. That is the delta V lah. Understand? That's why your battery has a positive and negative terminal. Because across it is a 9 volt difference. That means the positive terminal is 9 volt, the negative terminal is 0 volt, like that. Understand? So this is the delta V. Yeah, it's like 9 minus 0. 9 volt. Yeah. So got potential difference built up between the two plates. Understand? That's how we charge our capacitor. Understand? I can't see your at least you know what is your 9 volt battery, the one, the big one, yeah, and then you have is it then this one is round one, the round one is negative, this one is positive, that one 1.5 volt battery is this one is positive, this one is negative. Got delta V, yeah, in between the two terminal, got delta V, yeah, this one got delta V, yeah. One, that means the negative terminal is 0 volt, the positive terminal is 1.5 volt. Okay, like that. So this is how we charge our capacitor using a battery. Okay, now class, back to our capacitance. Back to our capacitance. Sorry for a very long explanation. So capacitance is C, and is charge over voltage. What is it mean by? Okay, let me. This is a capacitance. This is the charge, and this is the voltage. Or we can put this as potential difference. Actually, this is delta V, class. This V is delta V, potential difference or voltage. But why we just put V? Because we want to simplify the writing. Yeah, we want to simplify the equation. So actually we consider delta V is V lah. For this chapter, we consider delta V is V. Yeah, starting from chapter 2. For chapter 2, okay, we simplify the writing, so we consider delta V as V lah. Yeah, so that we don't need to always write the delta. Yeah, okay, we want to simplify the writing. Okay, unit capacitance is farad, charge is coulomb, and delta V is voltage. Okay, so capacitance has two unit lah. It has either farad or you can write as coulomb per volt. Yeah, just like the notes. Yeah, just like the notes. Where is it? Yeah, you see, farad or coulomb per volt. Understand? Okay. What else? So what is actually mean by capacitor is charge over voltage. Yeah. So if I give you a value, let's say I give you a value, 10 farad. What is mean by 10 farad plus? So you apply to this formula, 10 farad is actually, what we can say is 10 coulomb per volt. What is mean by 10 coulomb per volt? It is means by 10 coulomb over 1 volt. Understand? 10 coulomb over 1 volt. So, I give you two capacitor. Let's say I have CA is 10 farad, and then I have another one. CB. CB is 100 farad. 100 farad, which is 100 coulomb per 1 volt. Can you see the difference, class? Can you see the difference? So I have two capacitor. One is 10 farad. Okay. If I connect to a battery, of 1 volt lah. 1 volt. I connect the capacitor to a battery of 1 volt. Delta V, potential difference delta V. Okay, remember the formula delta V. Okay, how much charge is stored in the capacitor? Yeah, this is a capacitor A. Okay, and then I have another capacitor with 100 farad. I have another capacitor with 100 farad. Also, I connect to a 1 volt battery. This capacitor is 100 farad. So between A and B, which one store more charge? You see, this 10 farad, if you charge up by a 1 volt battery, it will store how many charge in the capacitor? 10 coulomb. It store 10 coulomb. So in capacitor A, it store 10 coulomb for 1 volt. For the 10 farad capacitor, it can store 10 coulomb per volt. But for capacitor B, it store how much charge?
100.
For the same battery, same battery. This is the same battery. These two is the same battery. But which one has more ability to store charge? Which one has more ability to store charge? Which one store more charge?
B.
B. Yeah, B is 100 farad. For the same battery of 1 volt, the B has higher ability to store charge. So for the same battery, it can store more charge. It can store 100 coulomb for 1 volt instead of just 10 coulomb. So it has higher ability to store charge compared to A. Yeah, because it store more charge for the same amount of battery 1 volt. And then understand? It store more charge for the same battery. That's all. That's the meaning of capacitance. Charge over voltage. That means coulomb per volt. More coulomb for every volt. Higher capacitor means more coulomb for every volt potential difference. Okay, so let's say your battery is not necessarily just 1 volt. It can be let's say 9 volt battery. Let's say you use 9 volt battery to charge your capacitor. So if let's say you have a 10 farad capacitance, so if you connect to 9 volt battery, how much charge do you think you can store? Just use your formula, because we know C equal to Q over V, class. Correct or not? C equal to Q over V. So Q equal to CV. Q equal to CV. multiply above. So if you connect, instead of 1 volt, you change to 9 volt battery. Now you charge your capacitor with 9 volt battery. So how much charge is stored? So 10 farad multiplied by 9 volt battery, 90 coulomb class. Then the charge stored is 90 coulomb. If 1 volt, you store 10 coulomb. If you increase the voltage, you connect to a bigger battery, 9 volt, it can store more charge, 90 coulomb. Understand? That's why it say the charge stored is directly proportional to the potential difference across the plate. The charge stored is directly proportional to the bigger battery. Directly proportional to the battery. Yeah. That means apa maksudnya directly proportional. The charge the charge is directly proportional to the battery, the voltage. So the higher the voltage, the higher the charge. Directly proportional. Q is directly proportional to the V. Yeah. Understand, class?
Understood.
Good. So let's I think that's all. Yeah, that's all. Yeah. So now we need to look at maybe tutorial questions. Yeah, let's look at tutorial questions. Yeah, do the tutorial question 1. Yeah, let's do the tutorial question 1. Okay, let's do it. Yeah, so let's do this question, class. Yeah, so let's do the questions. Yeah, let's do this question. Yeah, I need your calculator to be ready because I don't have calculator. Oh, I have. I forget my handphone has a calculator. Yeah, calculator. Okay, so at least now you understand what is capacitance. That is a very important concept you need to understand. Important concept. Yeah, for objective questions. Now, two capacitors C1 and C2 connected in parallel. This one you need to learn about, parallel, series parallel you haven't learned, huh? Series parallel you haven't learned. So that means I cannot do this question yet. I cannot do that question yet. So you must learn about what is series and parallel. So never mind. So let's look at series and parallel. Yeah, that's good. Now, capacitor in series and parallel. So yeah, so capacitor in series. Just now is just one capacitor. Yeah, just now is just one capacitor. Now if you connect the capacitor in series, in parallel, what is the value, charge, voltage, capacitance? How to find the total capacitance? Total capacitance. They got a formula. You remember last time we don't use capacitor, we use series. Yeah, you learn. No, what you want? Sorry, I'm talking about. Do you remember last time in SPM, you are using resistor instead of capacitor? You still remember? You use resistor instead of capacitor. Uh, just now I cannot see your thumbs. Now only I can see. Okay. Well, let me. Okay. So you learn you last time you use battery, okay, and then connect a resistor 1, resistor 2, then resistor 3, and then you have an EMF. Yeah. So remember the total resistance. It is R1 plus R2 plus R3. This is for series. Remember that? Yeah. Correct or not? If parallel means how is the connection of parallel? Don't put EMF, we'll put just total voltage. Parallel means how? You have this. This is parallel circuit. Yeah. R1, R2, R3. Yeah, V total. So this is parallel circuit. Parallel circuit. Yeah. Parallel circuit. Dia punya what is the total resistance? 1 over R total. Use 1 over R. Correct or not, class?
Yeah.
Good. Thank you for the response. So this is a total resistance to find. I mean the whole resistance. Is this? But do you know that if I've changed to capacitor, first thing I want to tell you is I straight away go to the final point. If I use capacitor instead of resistor, if I use capacitor instead of resistor, let me capacitor or instead of resistor. Okay, this is put it as a C1, C2, C3. Okay, this one is series lah. So the total capacitance for this one is what do you think? Is it still follow the resistor? Still follow the formula?
No.
Definitely not. Look at the notes lah. You can note that the notes. If series is 1 over C. 1 over C. That one is capacitor in series. Instead of tambah-tambah. See that? It's 1 over C. Why like that? I don't think I want to explain today. This is quite an explanation. So I just leave it with this one. At least you can see the pattern. Okay. 1 over C. 1 over C for resistor is for parallel. Correct or not? It's for parallel. Capacitor in series. They follow the formula for parallel resistor. What about capacitor in parallel? What about capacitor in parallel, class? Parallel capacitor. You can refer to the notes. What is the formula it used? C1, C2, C3. It's parallel. Look at the notes. This is the V total, the total voltage. Look at the notes. What is the formula for parallel capacitor in parallel? Like this one. What is the formula? Surprisingly, it used the C1 plus C2 plus C3. Just like the resistor in series. The total capacitance. See that? The total capacitance is the C total is C1 plus C2 plus C3. Okay. Right. One. Yeah. See the pattern, class.
Yeah.
In the parallel capacitor use the formula for series resistor. The series capacitor use the parallel resistor. That's all I want you to see lah. See the pattern. Series one use like parallel resistor. Dia terbalik. Kenapa begitu? I don't want to explain today lah, yeah. So, that's all the pattern I want you to see, yeah. So remember this pattern, yeah, class. Can you remember? Can Okay. Now, I don't want to proceed for this one. Maybe I just do the question over here, yeah. Just do the question over here. This example. Maybe I just take this example. Yeah. Maybe just let me see. Which question? What is the charge? I think net charge calculate potential with charge to I think I start with the first example. I think this is quite easy lah actually, yeah. But never mind. Just try, yeah. So easy questions. Okay. Uh, okay. Today I just more on the concept of what is capacitance. That's all, yeah. Capacitance. Now, you have learned one formula. Remember the formula? You have learned this formula. Q equal to CV. Yeah. Or you can see is QOV lah. Yeah. The charge on plates of capacitor is 120 microcoulomb and negative 120 microcoulomb when they are connected to a potential difference of 6 volt. What is the capacitance of the capacitor? So how? So this is the charge. Yeah, this is the potential difference. That means the voltage. So what is the capacitance? Capacitance is C. Capacitance is C. So how? So you have 120 negative 120. What does it mean, this one? That means this one is capacitor is being charged by a battery of 6 volt. It's being charged by a battery of 6 volt. When it's being charged by a capacitor of 6 volt, the one plate become positive 120, another plate become negative 120. Understand? Micro coulomb. Yeah. So that means this was positive Q, this was negative Q. Okay. So want to find capacitance. How do we do? What do we do? Capacitance. Do you use 120 plus 120? Yeah. Do you 120 plus 120? Yeah. No. Look at the notes. Look at the notes, class. You see? Q is charged on one plate only, not both plate. Charge on one plate. One plate, just use charge of one plate. Don't use charge of both plate. Charge of one plate only. Charge of one plate. Okay? So don't go to add become 240. No, no. So it should be just one plate, 120 micro. That's all. Just charge of one plate only. Okay, divide by 6 volt. Do you know why is only charge of one plate? Do you know why is charge of one plate? Because it's just the flow of electron is only Q electron. Understand or not? Because it's just the negative Q coulomb of electron is being pulled, and then another positive Q the negative Q coulomb is being sent to the other plate. So the flow of electron is just Q coulomb. Understand or not? The flow of electron is just Q coulomb, not 2Q. It's not 2Q. Yeah. Q coulomb of charge is being pulled from this plate and then being stored on the other plate. So the charge flow is only Q coulomb, not 2Q. That's why it's only 120. Understand? That's the explanation. Okay, so 120. Don't go to put negative lah. No need to negative 120. It's just 120. Micro is negative 6 coulomb. Yeah, over 6 volt. So what's the answer? So divide by 6. So 2. So 2. And then exponent negative 5 lah. Farad. That's all. Yeah. Yeah, or 20 microfarad also can. Yeah. This one is actually 20 microfarad also. Yeah. Why we said negative 20? Because why is 20 microfarad? Because it's 20 negative 6. So it's 20 microfarad lah. Also can. Yeah. Now, question B. Question B, just like question A. Question B, let's look at question B. What is the potential difference across the capacitor if charge on each plate is 64 microcoulomb? So what is the potential difference if the charge on each plate is Q is 64 microcoulomb? So we just use the formula Q equal to CV. Use the capacitance 20 microfarad also, because we use the same capacitor, we don't change the capacitor, so the capacitor don't change, the capacitor is a constant value. So use back this value capacitance to find the new potential difference, new voltage. Charge on each plate is 64 microcoulomb. That means it changed battery already. Last time it used 6-volt battery, 6-volt battery. Now you change to another type of battery. Now the charge of each plate become less than 120, become 64. That means you change the battery already. Use a different battery to charge the capacitor. Okay, so let's find the new voltage. We can put this as a Q2 V2. Last time is Q1 V1. This time is same capacitor, just different battery, different charge. So the charge on each plate now is 64. Charge on one plate only, charge on one plate. So it's -6 coulomb. And then capacitance is the same capacitor, 20 microfarad, or put as I think we just put 20 this one use 20 microfarad. Micro is -6. Why we use this one? Because I want to cut off the exponent -6. Okay, V2. So I can cut off the -6. So what is my V2 class? What is my V2? My V2 is so divide by 64 divided by 2 is 32 kan? 32
Yeah.
divided by 10. 32 divided by 10 is 3.2 volt lah. Correct or not? 64 divided by 2 is 32. 32 divided by 10 is 3.2 lah. Last time is 6 volt, now 3.2 volt. Correct? Yeah, correct. 3.2 volt. That's correct. Yeah. So that's all, class. Very easy. Yeah. So I just use test one example for this one. So the rest is your homework, class. This is your homework. Try to do this question. Okay, that's all for today. Short and simple. Mainly the lesson today mainly is what's the meaning of capacitance, charge over voltage, and actually why is it insulator, how is the capacitor being charged up, why we must use insulator instead of conductor. I already explained all that. So if you miss out any point, you can refer to my YouTube video, because I will upload this video again in the YouTube channel. You can refer my to Pax Explain Physics channel, Pax Explain Physics, for those who are new, new student. Okay, so thank you, class. So see you again in the next tutorial class. All right. Okay, that's all for today. So that's all for recording.